Okay, moving into the last section of chapter 1, we start with talking about statistical notation. When we say statistical notation, we're talking about the symbols that we use in statistics to represent different ideas and particularly within calculations. So we're going to get some symbols here today, and in most chapters, not all, but in most chapters, we'll be adding some new symbols into our toolkit. So we're going to start with 3 symbols today. The first symbol is the letter X. Just like algebra, basically, this represents a variable. So an X is a raw score for a particular variable. So if I measure your age and measure their age and measure their age, every person has an X. It's a raw score. So when you see this, what you want to say to yourself is raw score. Don't say X. I'll talk more about this in a minute. Don't say the name of the symbol. Say what it represents. Because the name of the symbol doesn't mean anything. When it comes to crunch time and you're trying to answer test questions, X doesn't tell you anything. Raw score, that tells you something. The other thing we can have is a Y. Y is also a raw score. It's a raw score on a separate variable, on a second variable. Remember, in correlational research, we measure each person twice, once on each variable. We measure them once, get the raw score for variable X, height. Measure them once, get the raw score for variable Y, shoe size. So X and Y basically mean the same things. Outside of this chapter, we won't see Y's again until chapter 14 is when we'll go back to correlations. So most of our chapters, we're really only dealing with a singular variable. So outside of this chapter will be a while before it comes back. And our last symbol for the day is called sigma. We use a lot of Greek letters in statistics. You're going to use a lot of it in your notes, a lot of it in your answers. So get used to it. So for the Greeks, although it looks more like an E to us, but to the Greeks that is a capital letter S, hence sigma. They picked the S, sigma, because it stands for the word summation. So raw score for variable X, raw score for variable Y. This sigma, it means summation. So again, when you're encountering it and working with it, don't look at it and say sigma. Look at it and say summation. Sigma doesn't tell you much, but summation is an instruction to sum. Oh, it's telling me to add things up. Oh, that means something. Don't get lost under the symbols. Now, as we start talking about calculations, they're not generally that hard in statistics for most folks, even though they look scary because of all the weird symbols in them. Add, subtract, multiply, divide, square root with a calculator in your hand. That's really all there is to it. But we do have to make sure we're doing everything in the correct order. So the order of operations. If you're in this class, you've already passed algebra, you should already know your order of operations. However, in a statistics class, what you know is 4 orders of operation is actually 5. There's an extra step when you're doing statistical calculations. So the very first order of operations is the same as you've known it before. It's whatever is in your parentheses. Where do you start? Look for parentheses. So you start with parentheses, do whatever's inside of there. After your parentheses, you do your exponents. We don't really do any cubing, particularly not in introductory statistics. Squaring is really the exponent of choice, if you will. So first, whatever the parentheses are, then we take care of whatever our exponent business is. Then we do any multiplying and dividing. Again, left to right. You should know all that already. So we multiply and or divide. Now this is where it changes. Ordinarily, in the order of operations you know, next would come addition and subtraction and you'd be over. But before we get to addition and subtraction, you can see there's one step left. What calculation might that be? It's our friend sigma, summation. So whenever you see sigma, the sign for summation, it's an instruction. And it's telling you whatever is right next to it, add those things together. And do that until you hit another instruction. We're going to do examples in the next little video clip here. We're going to go through several of them. But sigma is saying add up whatever is attached to it, whatever is right next to it. So first tackle what's in the parentheses, then take care of your exponents, then multiply and or divide, then summation, then addition and subtraction. So what we're going to do in the last video clip here is I'm going to put some data up on the board, and we're going to do some practice calculations. Before I stop to start the next video, let me say that I'm not your algebra teacher. You should already know how to do algebra. It's a prereq for being here. But if you're a little rusty, A, in the back of your book are basic math reviews that can blow some of the rust off of that. And B, I am more than happy to help you remember some of that stuff. Just ask. Just let me know you need that help, and I'll be happy to, pardon me, I'll be happy to give you whatever tutoring you might need for that. But what's important here is that you start to try to think of our formulas, our calculations. We don't have any formulas yet, but the calculation is going to do, try to read it like an English sentence. If you read it like a sentence as opposed to babbling the names of symbols, it often tells you exactly what you need to do. So we're going to do some examples of that for the very last video section for this chapter right in the next video. See you there.